Am I audible to all? Let's start the class then. Am I audible to all? Good evening, everybody. Am I audible to all? Okay. Is it okay for all? Please let me know. Then I will start the class today. Okay, nice. I am audible. So let us start. So today we will start the academic series for Geotech, in which I would be covering certain basic aspects of geotechnical engineering, so that it will help you in forming a base of the subject so that you can study it further, and it will also help you to build your interest into geotechnical engineering, correct? So let's start today with a simple topic, and the name of the topic is also very simple, that is simple definitions. So this is lecture number 1 today, and I will be focusing on simple definitions in detail. Okay, this is my lecture number 1. So firstly I would talk about phase diagram, then I will proceed towards the simple definition. Okay, my dear friend. So I will talk about the phase diagram, and then we will talk about the simple definitions on the basis of the phase diagram. See, geotech is one of the most important topic in your civil engineering. You know, most of the exams have a good weightage on geotechnical engineering. In fact, GATE is carrying around 15 marks in geotechnical engineering in engineering services on any state service exam. Any of the exam of civil engineering, you will see that geotechnical engineering carries a very good weightage. So you can't leave this topic. You have to be strong in this topic. Unless you are strong in this topic, you won't be able to secure a good rank. And this series will help you make a foundation for this topic. So please watch this series up to the end so that you will develop an interest for this subject. No, beta, it's not exactly a crash course. It's an academic series. Crash course would come later on. Now we are covering an academic series just to help you to build a base or fundamentals around this topic so that you can study it further. And these topics that I would be covering here will help you to bring to have some to build some interest into geotechnical engineering as well. Okay, let's start then. So first let's talk about the phase diagram in detail. What do you understand by the phase diagram of a soil? If I talk about soil, what is a phase diagram of a soil that I have to show? Please focus here on the board once. I will show you the phase diagram of soil. So what do you understand by this phase diagram of soil? Huh? Okay, let me take a small diagram from here. You know, soil consists of soil solids as well as voids. Okay, very good. This would be a better diagram to keep here. Okay. let's see this. So soil, if you see soil, you take a soil sample, what do you find? What you will find in the soil sample? You will see certain randomly packed solids, and between these solids there would be void spaces. So there would be a lot of void spaces in between the soil solids, and these void spaces may be either occupied by air or may be occupied by, some voids may be occupied by water, or we can have the combination of both. So this is my random soil mass. It's a soil mass having a lot of soil solids, and between these soil solids we have a lot of soil voids, and these soil voids are either occupied by air and water. So beta, what I want to say, now I can represent this whole thing into a phase diagram. How? What I want to say here, please focus. So if we separate, it's an imaginary thing that I am talking, okay. If you take out all the soil solids from here, if you just take out all the solids from here and you concentrate it, or you pack those solids such that there will be no voids, it's a imaginary situation. You are not doing any such thing. Try to imagine what I am saying, that if you only take out the soil solids here, and if you randomly pack these soil solids, pack this soil solids such that there is no voids between the soil solids. It's a hypothetical situation. So the space that would be occupied by the soil solids will be this much. No voids are there. If you take out water from here and if you pack it, this will be the space occupied by water in the soil mass, and this is the space occupied by air in the soil mass. So this is the three-phase system. So soil mass, when it is partially saturated, means all the voids are not occupied by water. In that case, we have a three-phase system in the soil mass. And what are those three phases? First phase is solid, second phase is water, and third phase is air. It's a hypothetical situation that we have drawn here. It's a very, very hypothetical situation here, beta, that I have drawn here. In reality, you are not doing any such thing. Neither you are taking out the solids, or neither you are separating the water from the soil, nor air. Just a hypothetical situation through which we can represent what we want to say through this phase diagram. That in this soil mass, I have this much amount of solid, this much fraction of water, and this much fraction of air. And this phase diagram will help me in defining certain simple terms that we will cover it in the lecture today. Now, soil mass can be in a two-phase system as well, when the soil is either saturated or it is either dry. So, if the soil mass is saturated, then all the void spaces will be occupied by water only, solid and water. Soil is saturated. And if soil mass is dry, all the void spaces will be occupied by air only. So soil mass is generally a three-phase system composed of soil solids, water and air. The soil mass can be completely saturated or completely dry. In that condition, the soil mass is represented by a two-phase system. So when the soil mass is partially saturated, this is a three-phase system. And when the soil mass is either saturated or dry, then we will have two-phase system, in which the voids will either have water only or the voids will either have air only. So using this phase system, let us understand certain simple definitions through which we will study the soil mechanics. These simple definitions are very, very important, because throughout in soil mechanics we would be using these simple definitions only. Got my point till here? Any doubts? Can I proceed further, my dear friends? Can I proceed further? Any doubts till here? These PDFs you will get in PW app. That's very correct. These PDF, this lecture PDF you will get in PW app only. You can just download the PW app, and from there you can take this, and link you can find in the description of the video only. Okay, the link you can find it in the description itself. So let me proceed further then. Let's proceed further then. What do you say? Shall I proceed further, my dear friend? Shall we proceed further? Hmm? Okay. Let's see further from here. Shall I see again from here? Shall we see it from here? Any doubts? No doubts. Now, what I want to say further, let's see. Now, let's talk about the phase system, or certain simple definition based on this phase system. Let's consider that soil is partially saturated, that is, soil have solids and its voids have water as well as air. Now, while defining these simple definitions, we would be using the phase diagram. And while using the phase diagram, you should understand a simple rule that we will follow. What is that simple rule? That on the left side of this phase diagram, you will take only volumes, whereas on the right side of the phase diagram, you will take only weights. On the left side, you will take only volumes, and on the right side, you will take only weights. For example, this is solid. This much solid have this much volume. So, your Vs that you are seeing here, Vs is what, my dear friend? Vs is the volume of solids. Vw, this much water have Vw volume. So, Vw here, volume of water. Va, volume of air. No problem. This water and air is in voids. So, Vv is volume of voids. Vv is what? Volume of voids. Where Vv is equal to what? Va plus Vw. And V is the total volume of soil. V is what? Volume of soil mass, that is volume of soil. V is equal to what? That is Vv plus Vs, that is Va plus Vw plus Vs. Simple. Total volume will be Va plus Vw plus Vs, or Vv plus Vs. We can write like this also. Not a problem till here, you know. Now on the right side, we will take only weights. This much solid have how much weight? That is Ws. Ws is the weight of solids. Ws is what? Weight of solids. Ww is weight of water. W is weight of soil. W is equal to weight of water plus weight of solids. See, we have neglected the weight of air here. In the total geotechnical engineering, in all analysis, we never consider the weight of air, because the weight of air is very negligible as compared to what weight of water and weight of solids. But yeah, volume will be much higher, you know. You can't neglect the volume of air with respect to volume of water and volume of solids, because volume of air will have a significant value. You can't neglect it. But weight of this much air is very negligible. Even if you consider, it will not make much difference. We generally neglect it. For us, weight of soil is simply weight of water plus weight of solids. Now, using this phase system, we will now start defining certain terms. The first term that I would be defining today is known as water content. Let's see the definitions now. Now let's see certain definitions here. Okay till here? Any problem till here, please let me know. Then I will proceed further. I will show you the first definition now. Water content. Hmm? Please note till here. Any doubts till here you can tell me. I am coming in a moment. Please tell me if you have any doubt. Any doubts till here? Please let me know if you have any doubts till here. Then I will proceed further again. Any doubts till here, my dear friends? Any doubts till here, please let me know. Let's see beyond this. Let's see beyond this. first definition I am seeing now, first definition is water content. How do you define water content for soil? Water content is nothing but weight of water to weight of solids. You multiply it by 100, you will get your answer in percentage. Okay. Now the minimum water content, the minimum value of water content can be 0 for a fully dry soil. If you have a dry soil, the water content is 0 and there is no upper limit of water content. Water content can be greater than 1 or can be greater than 100% in few soils like bentonite clay, etc. Those soils can have a very high value of water content. So, water content does not have any upper limit, but it have a lower limit, that is 0. It can't be less than 0, it can't be negative, and it can be equal to 0 when the soil is completely dry. So, minimum volume value of water content is 0 when the soil is completely dry and there is no upper limit. Water content of fine grained soil is more than that of coarse grained soil, that is correct. Fine grained soil means when the grain size is very small, less than 75 microns like clays, and coarse grained soil like sands and gravels, those are known as coarse grained soils. Okay, sands and gravels. So clays have a larger water retaining power as compared to sands or gravels. Why? It has been seen that clay surface have negative charge on its surface and the size of clay particles is very less than 2 microns. So it have a very large specific surface area, that is surface area per unit mass or per unit volume. Due to its very small size, the total clay mass will have a very large surface area. As you reduce the size, the surface area, the specific surface area keeps on increasing. Now water is a dipole. There is a charge separation in water because of a higher electronegative value of oxygen. So there is a charge separation in water. You have a negative pole in water as well as a positive pole in water. The surface of the clay is negatively charged, so it can easily pull the positive pole of the water particle towards itself, and the specific surface area of the clay particles is very large, so it can assimilate or absorb large quantity of water without getting converted into liquid state. Thus, we can say that clays or the fine grained soils generally have more water content as compared to the coarse grained soil. Got it? Very simple. So, clay particles have negative charge on its surface. To this negative charge, it would be charge here. To this negative charge, water dipole gets attached. Thus, the retention capacity of water is more in a fine grained soil. So, the fine grained soil will have a larger water retention capacity. Very good. Now, let us see the next definition. Is it clear? Water content, the first definition, very simple. You can please see to it. Then I will proceed towards the next definition, that is the void ratio. Please see to it clear. Then I will proceed towards the next definition, my dear friends. Okay. Let's see further, my dear friends. So now the next definition is void ratio. How would you define the void ratio? How it is defined? Let's see how the void ratio is defined. Very simple. Now let's see how void ratio is defined. So void ratio is what? It's a ratio of volume of voids to volume of solids. E is equal to VV by Vs. This is how void ratio is defined. You multiply it by 100, you will get your answer in percentage. See, E is always greater than 0. Like water content does not have any upper limit, void ratio does not have any upper limit, because the soil which have water content more than 100% can have void ratio more than 100%, because these all water will be in the voids of the soil only. Now, void ratio cannot be equal to 0. Void ratio will never be equal to 0. Every soil will have some amount of voids. So, void ratio will have some amount of finite value. So, this void ratio value cannot be equal to 0. So, since a soil has to contain some void, so void ratio can never be 0, and there is no upper limit to void volume. The individual void size is larger in coarse grained soil, but the void ratio is generally more in a fine grained soil. E of clay is greater than 0.8. Generally, void ratio. See, your coarse grained soil like gravels will have larger void sizes, but the individual void sizes is smaller in the fine grained soil, but the overall the void ratio is more in the fine grained soils. Got my point? More you break the particles into smaller particles, more would be the void volume. For example, this I can show with the help of a diagram as well. Let's consider that we have a larger particle. This is a coarse grained soil. So you can see that in the case of coarse grained soil, the individual void sizes is large. You can see here the individual void sizes is larger in the case of coarse grained soil. Now if you see a fine grained soil means small particles. The individual void size is very small here. You can see here. See, the individual void sizes is very small here. You can see. So you can see the individual void sizes are very small, but overall the void volume will be more. As you break the soil into smaller particles, the void ratio, the void volume will keep on increasing. So void ratio for a fine grained soil will be more as compared to the void ratio of a coarse grained soil. You got my point? And it is seen that void ratio of clay is generally greater than 0.8, whereas void ratio of sand is between 0.5 to 0.7. So this is void ratio, second definition. Third definition, my dear friend, is about porosity or percentage voids. How would you define porosity of a soil or percentage voids? Porosity is volume of voids divided by total volume. If you multiply by 100, you will get your answer in percentage. This is percentage voids. It tells me how much percentage of total volume is occupied by the voids. Again, void volume cannot be 0, and here the porosity cannot be greater than 1 also. It is always between 0 to 1, because the denominator will always be greater than numerator. Denominator will have the volume of solids as well. So, denominator will always be greater than the numerator. So, total volume will always be greater than the volume of voids here. As simple as that. And the limit of n is between 0 to 1. It cannot be greater than 1, because denominator will always be greater than the numerator. So, it will always be less than 1 only. So, this is porosity. Now, let us see the next definition. Degree of saturation. It tells me how much of the void is occupied by water, that is volume of water to volume of voids into 100. The S is generally between 0 to 1. It can be equal to 0, it can be equal to 1. S is 0 when the soil is completely dry, volume of water is 0. S is if the soil is completely saturated, in that case VV will be equal to VW only. And what is VV, my friend? VV is equal to VA plus VW. So, if the soil is completely saturated, in that case my VA is 0. So, VV will be equal to VW, that is S is equal to 1 when the soil is completely saturated. So, S is between 0 to 1, and if S is between 0 to 1, it means the soil is partially saturated. Okay, 4 definitions we have seen. Now, let us see the next definition. Percentage air voids I will show you now. Please tell me all clear till here, then I will proceed further again. Please tell me, my dear friend, is it clear till here? Am I clear till here? Got my point? Let's see the next definition. Next definition is about percentage air voids. It's tell me how much percentage of air is in the total volume of soil. So Na is defined like this: volume of air divided by total volume of soil into 100, and answer will be in percentage. Na cannot be Na can be equal to 0 when the soil is completely saturated. In that case, the volume of air will be 0, but Na cannot be greater than 1 because denominator will always be greater than numerator. है ना? Got my point? This limits also you should remember. Air content, how you would define the air content? Air content is volume of air divided by volume of voids. It tells me how much of void volume is occupied by air. Simply AC is between 0 to 1. Okay. Now prove one thing. I have a question for you. You have to prove one thing, that S is equal to 1 minus AC. Prove this. Prove this. Try yourself, please. I am waiting. Prove this expression for me. Then I will give you one more expression. Prove this fast, please. Do it fast. I am waiting for answers. Okay? Do it fast. Solve, tell me fast. Chalo, let's try to prove this. Now let's see the proof here. Let us see the proof here. Now 1 minus AC is equal to what? 1 minus VA by VV. that is VV minus VA upon VV. VV minus VA is VW upon V, that is equal to S. Proof. So 1 minus AC is equal to S. I can write like this, not a problem. Okay. Now let's see one more term here. Bulk unit weight, that is total weight of soil divided by total volume of soil. This is my bulk unit weight of soil. Simple definition, not a problem. Now bulk unit weight of solids, that is the unit weight of solid is the unit weight of soil solids through which the soil is made. No words will be there. It is simply weight of solids by volume of solids, that is gamma S, unit weight of solids. Next is unit weight of water, that is gamma W is equal to weight of water by volume of water. And if nothing is given, you will always take gamma W as 9.81 kilonewton per meter cube, as simple as that. Okay. Now dry unit weight of solid, that is gamma D, that is equal to weight of solids by total volume of soil. See, one thing you should understand, if you dry the soil beyond its just saturated state, its volume will be constant, that is volume of soil does not change on drying. If we have a partially saturated soil, if you dry the partially saturated soil, its volume will not change and weight of solids will also not change on drying. So gamma D will be constant. Okay. So when you dry a partially saturated soil, what will happen? Only the water from the voids will keep on evaporating. The volume of voids will not change. So total volume will be constant. Weight of solid is also constant. So gamma D will be constant. So volume of partially saturated soil will not change on drying. Now what is the use of this dry unit weight? This dry unit weight is used to study the compactness of a soil, how much densified it is. So let's see this. V1 is, see, after compaction what happened? You had a soil, you compacted it. After compaction what happened? The air volume reduced, but the weight of solids is same. So what happened to gamma D? Gamma D1 is weight of solids by V1. V1 is greater than V2, obviously. V1 is what? V1 is greater than V2. So your gamma D1 will always be less than gamma D2 after compaction. So more is the gamma D, means more is the densification of the soil. So the dry unit weight is used to measure the denseness of the soil. A higher value of gamma D indicates that more solids are packed in a unit volume of soil. Thus, we have a more compact soil. Okay, simple. So degree of denseness in an embankment can be checked with the help of gamma D. Next is saturated unit weight of soil, that is weight of saturated soil divided by volume of soil. This is known as saturated unit weight of soil, and it will depend upon the water content of the soil, obviously. Okay. See, now you can saturate this statement. I can prove how. There is two methods to saturate the soil. Either add excess water, the soil will get saturated because soil solids have more affinity for water. So when you add excess water, what happens? The air voids will be expelled out and the soil will have only solids and water in it. Or you can keep the water content constant, apply infinite compaction energy. So you are making the air void 0 here. So mechanical energy is required. This is a 0 air void state. This is a hypothetical situation. And in both these situations, the gamma sat will be different. And obviously, my gamma sat 1 would be less than gamma sat 2. Why? See, when you are removing the air here, what is happening? See, if you take 1 meter cube of soil here and 1 meter cube of soil from here, if you take 1 meter cube of soil here, you will find that solids are more, solids are less, water is more because you have added excess water. Here you have not added water. So if you take 1 meter cube of soil here, you will find that solids are more, water is less. Means 1 meter cube of soil here will have more weight as compared to the 1 meter cube of soil in this condition. So gamma sat 2 would be greater than gamma sat 1, and you can see water content of both the conditions is different. So gamma sat depends upon water content. See, if nothing is asked in exam, and if if nothing is said in exam, and if the examiner asks to report the saturated unit weight of soil, always report this gamma sat only. If the examiner says that we have made the air void 0, or we have applied infinite compaction, or he simply says that report the gamma sat after removing air, then only report this gamma sat 2, otherwise not required. Then we have submerged unit weight, that is buoyant weight of soil divided by volume of soil. This is gamma sub. Okay. The gamma submerged is equal to gamma sat minus gamma w. That I can prove also. Buoyant weight of soil, how you will calculate? Buoyant weight of soil is equal to buoyant weight of soil is equal to what? That is total weight of soil minus buoyant force. That is gamma sat minus gamma w into total volume of soil. So gamma submerged will be equal to what? Buoyant weight. This is my buoyant weight, divided by total volume of soil. That is gamma sat minus gamma w. Okay, my dear friend, very simple to understand. Now I have a last specific gravity of soil solids. This is my last definition. That is GS. How would you define GS? GS is the ratio of gamma S upon gamma W. This is how you define GS. It is the unit weight of solids with respect to unit weight of water. So these are the simple definition that I would be using in the soil mechanics. Just a small question before winding up the class. Arrange these unit weights in decreasing order. Please do this. Gamma S, then gamma sat, we have seen gamma T, we have seen gamma D, and we have seen gamma submerged. Arrange these unit weights in decreasing order. Please do it. Arrange these unit weights in decreasing order. Do it fast. Do this question, please. Make it fast. Okay, so obviously the unit weight of solids is more than gamma sat. Gamma sat is more than gamma T. Gamma D is more than gamma submerged. Why gamma D is more than gamma submerged? That I will prove tomorrow. So see, gamma submerged is approximately half of gamma sat. Gamma sat is nearly 20. Gamma submerged is gamma sat minus gamma W. If you assume gamma W to be 10, gamma submerged will come out almost half of gamma sat. Okay. And tomorrow mathematically also I will prove why gamma D is greater than gamma submerged. These are the simple definitions that we were studying. Tomorrow from here only we will start our discussion again, and tomorrow we will see the interrelations between these terms. Okay. All the best everybody. Bye bye. Take care.